look at the final subtopic. This whole week now, we're going to look at the final subtopic, which is the equations of loci. Okay, loci, or the loci is a plural word for the word locus. Okay, so the first question is, what is a locus? So a locus is a path. Okay, is a path that is represented mathematically. Okay, so a locus is a path, is a pathway for a moving coordinate. Okay, a path for a moving point. Okay, that we represent it mathematically by using an equation. Okay, so of course the path must satisfy a certain condition. You cannot just simply jalan mana-mana yang kamu suka lah. Okay, so for example, the first one is the distance from a moving point. The distance of a moving point from a fixed point. Okay, so that means one fixed point, one moving point. Okay, this is the first one. So you write down there lah. Okay, one fixed, one moving. Okay, and this locus is represented by this. Okay, this one. So the locus of a moving point where the distance from a fixed point, one fixed point, one moving point, is the locus P. Okay, so this is the path. So if, let's say, this is the moving point. Okay, titik yang bergerak adalah ini. This is the fixed point. Okay, so the locus or the path, okay, the locus or the path of this moving point, because you want it to make sure that it is a constant distance, always a constant distance. So the locus, okay, the locus is a circle. Okay, the locus is a circle because the fixed point, okay, the fixed point is also known as the center of the circle. Okay, so if this point over here, if let's say this point, saya jalan, and then I come over here, you find that the distance is still the same. If I keep moving in the same circle and I bring the point over here, the distance also is the same as the original distance. If I bring it here, the distance is also the same as the original distance. So this locus is a circle where the fixed point is the center. Okay, and of course you have the radius r. Okay, now the second one is there is a ratio involved, the ratio of a moving point from two fixed points. So in this case, this is two fixed, one moving plus ratio. Okay, there's always a ratio involved. Okay, so this will be how it would be. Okay, this will be Q. Locus of a moving point where the distance from two fixed points has a ratio, okay, of m to n. Okay, so it is also a circle. Okay, it is also a circle. Okay, but okay, distance between m and n, or not between, distance with, okay, distance with m and n is at a ratio. Okay, that means sini dan sini dia punya jarak bahkan. Okay, here is the distance of m and the distance of n, there's a ratio. If you bring the point over here, this distance here and this distance here, the ratio is still the same. If I bring the point over here, okay, if I bring the point over here, the distance to m and the distance of m, this is m, this is n, the distance is still the same ratio. The distance may be different, but the ratio is the same. Okay, so two fixed points, one moving point, and ratio, okay, is also a circle, but the distance is always at the ratio. All right. Now the last locus that you need to know is the locus of a moving point, one moving point. Okay, two fixed points. Okay, two fixed points, but the distance now is not a ratio. The distance is same distance. Okay, now if that's the case, this is the locus. The distance is always the same. Here, the distance here and the distance here is always the same. Okay, so this is locus R, and locus R is called a perpendicular bisector. Okay, so at Form 4 at Maths, you are required to know these three locuses. Okay, these three paths. If it is, I repeat, if it is one fixed point, one moving point, okay, then it is a circle, and the fixed point is the center, okay, of the circle. If it is two fixed points but one moving point, and then there's a ratio involved, it is also a circle, but the distance always is a ratio. Okay, the second one. The third situation is two fixed points, one moving point, but the distance is the same, not ratio. Okay, then the locus is a perpendicular bisector. So you must know the conditions, and then you must know what kind of locus you're looking for. Okay, because you have to describe the locus also. Okay, and then once you do that, then we can find the equation of the locus. Okay, so let's first talk about this. The equation of a circle with a center AB and radius this one is this one. Okay, x minus a squared plus y minus b squared equals r squared. Okay, whatever it is, let's remember this. The original, then the first formula you've actually ever learned when you were doing coordinate geometry, way back in form, I don't know what, is the distance between 2 points. Okay, the formula for distance between 2 points is x1 minus x2 squared plus y1 minus y2 squared. This is the basic formula, okay, that everybody has to know. X1 minus x2 squared plus y1 minus y2 squared. Okay, and then the second thing is, and please write down this in your module, okay, the locus point, the locus point is always, okay, x and y, because the locus point always changes. Okay, the locus point always changes, so we just give it the coordinate x and y. The rest of the coordinates we have to substitute in. The locus point is always x and y, because at the end of the day, apa yang kita mau cari adalah the equation. So now we have a locus of a moving point, okay, one moving point from one fixed point, and the distance is always constant. So this is situation number 1. Okay, one fixed, one moving, the distance is constant. Okay, so we know that the center of the circle is the fixed point. Okay, the fixed point is the center of the circle. So we look at this. Point P, okay, so this is the locus. How do you know it's a locus? Because it says move. Point P moves, means P is the locus. Okay, that means if it is the locus, P, the coordinate of P is x and y. Remember I said this just now? The locus point is always x and y. We don't care what the number is. I just want the letter. Okay? The point P moves means it is the locus point, and the locus point is always P, x, y. Okay? Distance is always 5 units from this one. So this is the fixed point. Okay? And the distance is always 5. So let me put the point is -3 and 4. And then the distance is always 5. Now, if I draw this, okay, one moving point, one fixed point, distance is constant. So it is a circle, okay? It is a circle where this is the locus P, and this is the fixed point, Q, -3 and 4. So this distance over here is 5. Okay, so that's how it will look like. So describe fully the locus of P. Okay, the locus of P is a circle. Okay, the path, okay, dia punya perjalanan adalah a circle, okay, with a center. And what is the center point? Center is Q, -3 and 4, and radius of 5. Okay, that is how you describe a locus. What is the shape of the locus? And there's only two shapes. Okay, take a look at it. There's only two shapes that you will learn. Okay, it's either circle or it's a perpendicular bisector. Okay, if it is a perpendicular bisector, what is the condition? It must be two fixed points, one moving point, and the distance is constant. Okay, it's a circle. But sorry, it's a perpendicular bisector. But if the locus is a circle, then it is one fixed point, one moving point, distance constant. Or one moving point, two fixed points, and the distance is at a ratio. Only these two situations will have a locus circle. Okay, so you must always remember the condition, then you know how to find how to describe the locus. Okay, the locus of P is a circle with a center Q, -3 and 4, and a radius of 5. The distance is 5. Okay, so let us put this distance between 2 points, okay, formula inside. Okay, so you will have x minus -3 the whole thing squared plus y minus 4 the whole thing squared, square root the whole thing equals to 5. Okay, let me write the formula for you again. The distance equals to x1 minus x2 squared plus y1 minus y2 squared, the whole thing square root. Okay, and as I said before, the distance is between P, the locus, and the fixed point. That's why it's x minus -3 and y minus 4, like this. Okay, the whole thing square, and you know that the radius is the distance. They already told you what is the distance. Okay, and so once we get that, okay, once we get that, we can simplify this lah. So how do I change this, okay, to become this? Okay, this is what we want. This is our final answer. The equation of a locus always looks something like this, like very complicated like that, like x squared plus y squared plus 6x minus y. Okay, this is very long, but can run very easily. Okay, first thing you do is you move the square root across. Okay, so this becomes 5 squared. Okay, this will be x plus 3 squared plus y minus 4 squared. Okay, I'm going to change this over to I'm going to change this over here. Hold on. Okay, so x plus 3 squared plus y minus 4 squared equals to 5 squared. Is this, what is this? Hold on. Y minus 4 squared. Okay, so each of this, you have to expand it. Okay, you expand it. So you get x squared plus 6x plus 9 plus y squared minus 8y plus 16 equals to 25. Okay. Again, I'm reminding you, this one, you need to make sure that you know how it becomes like this. Okay. If you don't remember, go and watch the old videos like chapter 2. Okay. Now, there's nothing much we can do about the x and y. We can only do something with the number. Okay, so x squared plus y squared. I'm going to bring this first, all the squares, plus 6x minus 8y, and then all the numbers, plus 9 plus 16 minus 25 equals to 0. I feel that I'm getting the wrong answer. Hold on. Okay, so 9 plus 16 minus 25. Okay, you will get 0. So x squared plus y squared plus 6x minus 8y equals to 0. Calculate this. 9 plus 16 minus 25 is 0, bahkan. Okay, so we will get the answer that we were looking at originally, okay, which is this. X squared plus y squared plus x minus 8y equals to 0, and that's it. Okay, that's the equation of the locus. Okay, so you find that in this case, okay, if the locus is a circle, okay, and I want you to write this note down here. Okay, if the locus is a circle, okay, if locus is a circle, okay, the equation will have x squared plus y squared, yada, yada, yada. So you expect this kind of answer, okay, for a circle. And there are only two situations, okay? There are only two situations where the locus is a circle. Situation number one, I repeat this so many times already. One fixed, one moving, distance constant. Situation number two, two fixed, one moving, distance and ratio. Only these two will have circle equation. The circle equation always starts with x squared plus y squared, yada yada. Yeah lah, it can be 3x squared plus 2y squared, plus, blah, 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 blah. Yeah lah. But you need to have the idea, oh, okay, if the equation got x squared plus y squared means it's a circle equation. Okay, so this is an introduction to what a circle equation is. Yes, even circle also got equation one. Okay, all right. So first homework for the day is question number 82. Okay, I just want you to take note of this. The distance from the midpoint of A and B. Okay, so the fixed point, okay, the fixed point is this one, the midpoint of A and B. Okay, so before you substitute this one, you have to find the midpoint first. Okay, find the midpoint first. Okay, this is the hint lah I want to give you. Find the midpoint first and then only you substitute like this. Okay, because the locus is P bahkan, so we always set it as PXY. Okay, so this one, be very careful. This is the midpoint, okay, of A and B. How do you find midpoint? Go and look at the beginning of your module again. Okay, all right, let's do question number 83. A point P moves along. Okay, once again, P moves along means that P is the locus. So if it is a locus, P, X, and Y. No need to think. Okay, definitely P is unknown lah. With a circumference of a center with a center of A23. Okay, A23. So that means this is the fixed point. Okay, the center is already given, A23. Now the circumference passes through point Q at -2 and 0. So now the problem is they never give you the distance. Okay, they never give you the distance, but they only give you a point that it passes through. Okay, okay, what does this mean? Fixed point is over here. This is point A. Okay, your PXY is always going to be moving along here lah. Okay? But it also says that the circumference passes through Q, -2, 0. That means somewhere over here is -2 and 0, Q. So the question is, can I find this distance? Can. Okay, I can find the distance because I have the distance formula ma. Okay, so the first step is find the distance. Okay, distance of A and Q. And then only find the equation of locus. Okay, so let's get around to doing this. So A is 2 and 3, Q is -2 and 0. Okay, A is 2 and 3, Q is -2 and 0. If I'm making a mistake in the copying, please let me know, okay, so that you don't just allow me to continue on and making mistake all the way. 2, 3, -2, 0. Okay, so we can find the distance first. Okay, we can find the distance, which is 2 minus -2 squared plus 3 minus 0 squared. Okay, square root. Can you tell me what is the value for this, please? Okay, the distance will be 5. So now you have the distance 5 and you have the 2 points, right? The locus point is P and the fixed point is A, 2 and 3. That's the fixed point. Okay, so to find the equation of locus, okay, the equation of locus will be x minus 2 squared plus y minus 3 squared equals to 5. Sorry, square root. Okay, the same thing like we did for the first question. So we need to find the distance. That's the only difference between the first question and this one. Okay, this question, the distance they never give you. So you have to take another extra step to find the distance. Okay, once you have the distance, then you just put it into the equation of the locus. Okay, what is the first step we do? The first step we do is we move the square root over here. So it becomes x minus 2 squared plus y minus 3 squared equals to 25. Okay, then expand. So this is x squared minus 4x plus 4 plus y squared minus 6x plus 9 equals to 25. And just like the question just now, we cannot really do much about all these 4 because got no kawan. So we bring it all together. X squared plus y squared. Ta-da-da! Circle equation, x squared plus y squared. Okay, minus 4x minus 6y. Sorry, this is y. Okay, plus 4 plus 9 minus 25 equals to 0. What does this give you, everyone? Four plus 9 minus 25. Y squared minus, 4x minus 6y minus 12 equals to 0. That's it. Okay, this is our equation of the locus. You cannot do anything already. You cannot plus anything, you cannot minus anything, so just leave it like that. Okay? As long as you need to set in your mind, okay, equation of locus, if it is a circle, means sure got the x squared, y squared there one. Sure got one, definitely must have. Okay, because it's equation of circle. Oh, about minus 20. Why is it minus 20? Sorry, minus 12. Okay, fine. Minus 12. Okay, minus 12 equals to 0. So we got it right, lah. Okay, so your second homework for the day is question number 84. Okay, the same thing. Okay, P, Q, and R lie on the circumference of the circle with a diameter PQ. Okay, now guys, look, diameter PQ means what, Okay, P, Q, and R all on the circumference. So this is the circumference. Sorry. Okay, so let's say this is P, this is Q, and somewhere over here is R lah. And then they say that PQ is the diameter. Okay, so think about this. This is a circle, right? One fixed point, one moving point, and the distance. Okay, one fixed point, one moving point, and then the distance. So this one is a little bit more complicated. So think about it. R is our locus. So that one, no need to think. R is our X and Y. The problem is I don't have the center of the circle, but I have the diameter. Kan? If I give you the diameter, what is the center of the circle known as? What do you think? If I give you the diameter, the center of the diameter is known as, okay, it is called the midpoint. And we know how to count the midpoint, remember? Okay, we know how to count the midpoint. The center is the center. Okay, so you have this point, this is 2 and 6, and you have this one, -4 and -2. Okay, so you find the midpoint. That is the center of the circle. Okay, so the first step is find the midpoint. Okay, very good, David. Secondly, once you find the midpoint, you still need to find the distance because you only have the locus point and the center, but you don't have the distance. So you have to find the distance. Okay, between the midpoint and any point lah. Okay, you can use point P, you can use point Q, the distance is the same. Okay, and then only you find the equation of locus. Okay. So this part, find the distance and find the equation of locus, we already covered in this question, 83. Okay, so we just add another extra step, which is now we have to find the midpoint. That's why in coordinate geometry, you cannot just everything separate one. You cannot. It's all connected one. Okay, everything that you learn in the past, okay, is all connected, and we see it in this kind of question. Okay, in the locus question. All right. So your second homework for the day is question 84. First homework is question 82. Okay, but let's continue. I want to answer another question now. Given the points A and B, find the equation of the locus of the moving point P. Okay, locus of the moving point P. Therefore, P is the locus, X and Y. Okay, we're not interested in the coordinates. We just know that it's moving. So we just call it X and Y. But now we are seeing this word right angle. We are seeing this 90 degree. This question is about the same, 85 and 86. Okay, it's about the same question. Okay, so what do you have to do if it is a right angle? Okay, let's take a look at this. We have to understand the concept of the circle and why is it a right angle. Okay, so let me draw again. If you remember in circle, okay, okay, if this is the diameter, this is the center. Okay, this is the diameter. Okay, now let's say I have a point over here. I have point P. Okay, and the two ends of the diameter, okay, if let's say I join towards P, it's always going to form a 90-degree angle. This is something you learned when you were in, I think, Form 2 or Form 3 lah. Okay, no matter where P is, let's say I change lah. Okay, I put the diameter the same here, but now I move P over here. Okay, the two ends of the diameter, when it joins together with P, it's always going to form 90-degree angle. If I move P to the other side, here is the center. Okay, if let's say I move P over here, this end of the diameter joined to P, this end of the diameter joined to P, also 90 degrees. Okay, always will be 90 degrees. Okay, so when you see a question like this, okay, find the equation of the locus P such that the triangle APP is always at the right angle at P. It's actually the same question as question number 84. Okay, we have A and B, 2 and 4. Okay, so let me draw this. Astaga, sorry. Okay, let me draw this. Let's say this is A, this is B. This is A, 4 and 6. This is B, 2 and 4. And then we have P that is on the circumference of the circle. Okay, can I find the center? Can. And we can find the center. Okay, and why do we want to find the center? Okay, hold on. So this is the locus because it always forms a 90-degree angle. I need to find the center because the locus is a circle. Okay, the locus is a circle, and circle you must have one fixed point, one moving point, and the distance. Okay, so can we find the midpoint for this? Can. Okay, can you guys find the midpoint and tell me now? Okay, the midpoint will be 3 and 5. That means here the center is 3 and 5. Okay, that's the first one. Second one is you need to find the distance. Okay, the distance is always from the center to the circumference. So either 3 and B, either the center and B or the center and A. Okay, can you take some time? Distance of, let's have AC, let's do AC lah. Okay, since your class is 4 AC, so we find 4 AC, I mean A and C. Distance of 4 to 6 and 3 to 5. What is the distance? Can you quickly count down? Yeah, probably decimal. 1.4142. 1.4142. Hold on now. Yeah, 1.4142. 4142. Okay, so the distance is 1.4142. Okay, the distance is decimal, so decimal lah. Okay, no problem. But now we have enough information already. We have the center, we have the distance, and we have the locus point. Okay, so we can do x minus 3 squared plus y minus 5 squared equals to 1.4142, and then this whole thing will be square root. Okay, so the first thing you do is you move the square root across, same thing. Okay, move the square root across, this will actually give you 2. This will be x squared minus 6x plus 9 plus y squared minus 10y plus 25. Okay, equals to 2. Is it? Squared. Yeah, about 2 lah. Okay, about 2. So then you can put it up. Okay, you will get x squared plus y squared minus 6x minus 10y. Then you have 9 plus 25 minus 2. You get 32. Okay, equals to 0. So same question. Okay, same. Actually, the step is the same, exactly the same as number 84. Find the midpoint, find the distance between the midpoint and any point, and then find the equation of locus. Okay, so this module is very good. It gives you step by step. It gives you the easy one first, and then after that they add the distance, and then after that they add the midpoint. So if you answer question number 84, you can answer question number 85. You just have to understand that when you see 90 degree, okay, of at a circle, you are still talking about the same locus. Okay, locus you a circle, one fixed point, one moving point, and you have to find the distance. So your third homework for today, okay, is question number 86. 今天是 6 of 9. Okay, 3 homework only. I'm going to give you 3 questions for today. Okay, and everyone, if you don't know how to do this one, you look back at the question before. Okay, so I don't give homework, I just simply want to know. I think about whether you can do or not one. Okay, can one. You look at the question before and see how to answer. It is the same step. Okay, we learn and we build our kemahiran from there. Okay, let me look at this next question. Now, given the locus P with a center of AHK, so now they don't give it a center, they just say it is one. And the diameter 13 units is this one. Okay, find the coordinates of point A. So bad, so evil. Okay, so let's put it inside first lah. Okay, first we're gonna have the locus is P, X, Y. Our center, unfortunately, got no this one lah, A, H, and K. So weird. Okay, now they give you the diameter is 13 units. Okay, remember this, circle diameter is 13, but I know that if this one whole thing is 13, the center until the locus is 6.5. Divide by 2 lah. Okay, 13 divided by 2 is 6.5. So let's put it in, and then they say everything is equals to this one. Okay, x squared plus y squared minus 5x minus 12y equals to 0. Okay, so pelan-pelan. Let's do with the formula that we know first. Okay, x minus h squared plus y minus k squared equals to 6.5. Okay, the whole thing square root. Okay, equals to 6.5. Okay, so absolutely can one. Okay, so same thing, move the square root across. So you get x minus h squared. Oh, sorry, you know what? Let's immediately do this. X squared minus 2hx plus h squared plus y squared minus 2 ky plus k squared equals to 6.5 squared will give you 42.25. Okay, now let's rearrange everything again. X squared plus y squared minus 2hx minus 2ky plus h squared plus k squared minus 42.25 equals to 0. Okay, now let's compare it with this, because this is the final answer already. Don't have h and k. Let's compare. X squared plus y squared minus 5x minus 12y equals to 0. Okay, so the whole thing over here is missing. This one is equals to 0, no need to say. But when you compare this, let's compare this, guys. Look, this is x and this is x, right? Negative 2h and negative 5. So I can say that 2h equals to 5. Because both is x, ma. Oh, so h equals to 5 over 2. Okay. Can I do the same thing with k? Can. Because negative 2k equals to negative 12. Therefore, 2k equals to 12. K equals to 6. There. Okay. Quite easy actually. Okay. But you just have to, you just have to tahan with the H and K and the so many letters. That's the only one that you have to tahan. Okay, then after that, you just compare. Compare the up and compare the down. And you say, oh, okay. Don't need even to look at this. Okay. What? Nothing to do. Okay. Don't need to do that. We just compare the one that we can compare so that we can easily get the H and the K. Okay, same thing with this. Okay, same thing with this. Now, first of all, let's look at this. This coordinate M over here. Okay, coordinate M, if you take a look, the X coordinate is 0. So I can say this is 0 and 0 and M. I'm going to call this M. Okay, for the Y coordinate. Okay, now we find that they say that such that the distance from point M0H is always equal. Now we know the distance over here. Okay, can we find the distance? This is 0, right? 0 and 0. So the distance. Okay, the distance is 0 minus 0 squared plus 0 minus M squared. Square root. Okay, so the distance will be M. After you calculate everything, you will get the distance equals to M. Okay, so let's now put it with this. Okay, so x minus 0 squared plus y minus M squared equals to M. Okay, the square root. Okay, the equation of locus, that is the equation of locus. Okay, let me simplify this. X squared plus y squared minus 2my plus M squared. Okay, equals to M squared. I'm going to, pun kochi than this one over here. Okay, so M squared will automatically cancel and you will just get x squared plus y squared minus 2my equals to 0. Now let's compare it with this. X squared plus y squared minus 2my and minus 10y. So you can say that 10 equals to 2m. And I can get m already. M equals to 5. So there's a lot of comparing. Okay, there's a lot of comparing, especially when you come to questions like this. But if you don't really understand question number 88, okay, or question number 87 for that matter, okay, don't worry so much about it. The first things first that you need to make sure that you know how to do is how to calculate the equation of the locus. Okay, given this situation. So far, we are only talking about situation 1, We haven't even talked about situation 2 and situation 3 yet. Okay, situation 1, one fixed point, one moving point, distance is constant. Okay, the distance is already fixed. Okay, it's a circle where the center is the fixed point. Okay, let's begin with this. Tomorrow we will look at the other two. Okay, a circle with two fixed points, and another one is the perpendicular bisector. That one we'll look at tomorrow. But since today is the beginning of your study with the locus, I want to make sure that you have this idea in mind that when we do locus, when we want to find the equation of the locus, we always come back to this equation, which is the distance equation. x1 minus x2 squared plus y1 minus y2 squared equals to the distance. We always start with that. Okay, and then remember that the locus is always just the letter X and Y. Okay, so please answer question 82, 84, 82, 84, and 86. Okay, 82, 84, and 86 are as your homework today. Okay, and I will see you tomorrow. Yeah, I will see you tomorrow for our class. Okay, we are coming to the end of this chapter already, guys. So, yeah, just bertahan. Now, this last part of the chapter is actually a little bit challenging for a lot of people. Okay, so try your best. Okay, try your best to be able to just answer the homework questions. But if you feel that this subtopic is too much for you to handle, focus on the first three. The first three are much easier. Okay, parallel, perpendicular, find the, the m plus n. The one where you lompat one, then the m and n. Okay, the jumping formula. Okay, and then the area of the polygon. That one is much easier. Okay, so focus on that if you can't really handle this locus. But those of you that can, okay, go all out. Okay, because after a while, you'll find that the locus questions is like that only lah. Okay, there's no other question, right? It's just like that only. Okay? All right. So that's it for today. I will see you all tomorrow. Make sure you hand in your homework by today. All right. Take care, everyone. I'll see you tomorrow.